Good afternoon, everyone. My name is Venkatesh. I welcome everyone here on behalf of SkillLink. I'll be hosting the session today. For those of you engaging with SkillLink for the first time, we are an engineering upskilling platform focused on advanced technologies across domains like mechanical, electrical, electronics, computer science, etc. Our enterprise business focuses on employee training and upskilling across industries, including automotive, consumer electronics, ITES firms. Today's webinar is on automotive software architecture and classic AutoSAR. This is the 18th edition of our webinar for corporate professionals. Some pointers before we start the webinar. Please post your questions on the chat window. Mr. Ganapati will take it up towards the end of the session. We'll also share a feedback form towards the end of the session. Please spare a minute and fill it up. We'll not be able to share the deck, but however, we'll share the recording of the session with all the attendees. So about today's instructor, Mr. Ganapati is an accomplished specialist in automotive AutoSAR and embedded systems with over 10 years of industry experience. Driven by a passion for education and engaging with the next generation of engineers, he delivers lectures on advanced topics such as AutoSAR, embedded systems, RTOS, IoT, machine learning, etc. His expertise extends to C, OS, project management, and project lifecycle, making him a valuable resource for aspiring professionals in the field. We are excited to host and hear from you, Mr. Ganapati. Over to you.
Thank you, Venkatesh. Thank you so much. Thanks for the introduction. Hello, everyone. Good afternoon. Thanks for joining this session and thanks for showing the interest in AutoSAR 2. So, Venkatesh, can I start?
Yes, please. Your screen is on the Teams window. Yeah.
Teams only, right? Yeah, no problem. Yeah. Now, I hope you can see my PDF.
Yeah, it is on the deck.
Yes. Yeah. Thank you. Yeah. Once again, thank you so much for joining this discussion. So, I hope you are well aware about it. Automotive side, and somebody is already working in automotive, or somebody is actually want to move in automotive, or you are more enthusiastic towards automotive electronic side. So AutoSAR is actually, some people already here, or maybe you are working in a project, or you are going to enter into the project, or you already have a very good knowledge in AutoSAR, but you want to understand more deeper. But this webinar is completely about, as Venkatesh mentioned, overview about AutoSAR architecture and what are the topics and what are the technologies will be used in classic AutoSAR, and what is the difference between classic and adaptive. That's what we are going to cover it up in this webinar. So first, what is AutoSAR? Why AutoSAR is required? So that's very, very important. First, we have to understand it. So I have a couple of slides for you all. For first of all, AutoSAR is automotive open system architecture. So as it is mentioned here, it's an open system architecture. So it's applicable and available for everybody, whomever want to work in AutoSAR in automotive side, they can. But still, even though it's open system architecture, you have to pay license and you have to get the tool and you have to work on it. Only open, it's actually for everybody, is AutoSAR. How to work in the AutoSAR, that's only so open for everyone. But when you are coming to the tools and other areas want to utilize it, then there it's not actually open. You have to get the stack and different tool from a different vendor. So why exactly this AutoSAR is required? What exactly happened before this AutoSAR comes into the picture in automotive? So if you see this picture, before AutoSAR, application software and hardware is tightly coupled. So what is the application software and hardware is tightly coupled? Hardware is nothing about your microcontroller. So if you are working in automotive, you are well aware about ECU, electronic control unit, or engine control unit. So before AutoSAR, we cannot actually differentiate. That means we cannot divide application software from hardware. So you can think about I will tell you the one scenario. If OEM want some of the requirements or some of the development, or for an example, engine control unit, they want to work on the engine control unit, then in the case they have to go to the supplier and they have to ask for the complete software. They will deliver software along with hardware. But in later point of view, if OEM doesn't feel okay, they want to change the supplier, they want to change the supplier from one to another supplier, then in the case they have to follow the another architecture. The example is, in before AutoSAR, you can consider OEM is BMW, and the BMW is giving a requirement to Bosch, which developing the application software, also delivering a hardware. But later point of time, OEM BMW want to change the supplier. In the case when they are going to the another company, again they have to follow their own architecture, and again they have to spend a lot of time and money. The reason is, before AUTOSAR, application software is tightly coupled to hardware. We cannot develop somebody for the another application software for the hardware. That is not possible. But with the help of AUTOSAR, it's actually divide or differentiating or the application software from the hardware. That's because of AUTOSAR. Because AUTOSAR is coming up with the standard. It has a standardized API, and this can be applicable all the suppliers, all the service companies, all the OEM, everybody following the same standard. So it's easy for OEM to change the supplier to supplier, or they can go to the other service company, or the application software itself can be developed by OEM. Only they have to rely on a hardware. So that's the purpose we have a AUTOSAR. And one more thing is, if application software is developed for one ECU, the same application software can be reused for another hardware also. But in the before AUTOSAR method, the application software cannot be taken away from hardware. Again, if you want to work on another ECU or another hardware, again you have to develop your application software. That's the difference makes because of AUTOSAR. That's the reason AUTOSAR is very famous in automotive industry, because everybody start to follow the AUTOSAR. So again, AUTOSAR is nothing about a open automotive open system architecture. The benefit of AUTOSAR is it's coming up with the standard to make a differentiate between your application software to hardware. But before AUTOSAR, everything is all together. You cannot develop application software and you cannot buy hardware from somebody. But with the help of AUTOSAR, you can buy hardware from somewhere. Application software can be developed by OEM, or you can buy it from somewhere else. Okay, what are the benefits we have basically with AUTOSAR? As a OEM level, they can reuse their software modules.
Mr. Ganapati,
Yes, Venkat.
sorry to interrupt. Can you do slideshow?
Sure. Okay. Is it good, Venkatesh?
Yeah, much better.
Right. Thank you. So now in the OEM level, if you see the benefits of OEM level, they can reuse their software modules, and they can maintain the ability to compete on innovative function. At the same time, OEM is no need to depend on one particular supplier. They can change the supplier if they are not comfortable with the supplier, because everybody is following the same language that's called AUTOSAR. And when I use the word called language, AUTOSAR is not like a programming language C or C++. It's coming with the standard, and it is an architecture for all software development. So AUTOSAR is saying that how we can do the development of software, that's we have to follow the architecture. That's exactly called AUTOSAR. So how exactly this is supporting supplier? Now this will bring up with a new business model, because everybody is following the AUTOSAR. Then supplier no need to change the architecture for based on OEM. They can follow the same architecture. That's AUTOSAR. And at the same time, the development partitioning among suppliers. So the thing is, when they are developing something for one OEM, if the same logic or something need to be applied for somewhere else, they can again reuse it, because AUTOSAR is actually providing all the competent level to use it in multiple project or multiple variant. Now coming to the tool provider, the tool provider is actually, you can take example of ETAS or Vector. They are actually creating a tools for working AUTOSAR. So they are coming up with a different kind of tool, but now for creation of tool also, they need not depend on OEM or supplier or any of the technology. They can develop a tool to work in the AUTOSAR standard. And whomever is coming to new market entrant, for an example, now in automotive, if somebody wants to start a company, or they want to start a startup like Skilling, they want to work on a project, or they want to come up with a service company, you can consider Tata Technologies kind of. When they are coming to the market, they no need to worry about the complete automotive related things. If they can able to work in AUTOSAR, they can work in any other project, because all the OEM supplier, and we have a tool in the market which can support AUTOSAR. So in the case, it will be allowed, and it will create a way also to the new market entrant. So that is the benefit of AUTOSAR. This picture will create a more clarity how who all are working partner, that means core partners in AUTOSAR. So how exactly this AUTOSAR actually designed? As I mentioned, when there was a problem, not a problem, when there was no hold with OEM, so they want to bring up with a common standard format or architecture for software development in automotive. That's exactly this known 9 core partners have put effort. They bring up the AUTOSAR to the world. And if you see here, since because of AUTOSAR, we actually tools company, as I mentioned in the benefit of tool provider, if you see here tools, we are actually having a tool from ETAS, and Vector and other lot of companies are there. The DSpace, lot of companies are coming with their tools that can be used in the market, or it can be used the same for AutoSAR development. And standard software is actually for the base software stack developers. ETAS, Vector, EB, and VStar and KPIT, KStar. So those all are the stacks generally available which can support or can be fulfill AutoSAR completely. And when it is coming to tier 1 companies, like you can see the Delphi, BorgWarner, Denso, Valeo, ZF, Bosch, Continental, all these companies also part of the complete AutoSAR. They are also AutoSAR core partners, and everybody is actually equally contributing in AutoSAR community. So whenever the new AutoSAR version comes, everybody will put effort from their end, and they will bring up the new AutoSAR version depends on the needs. For an example, AutoSAR 4.2.2, it's a standard version earlier. Now we are coming up with AutoSAR 4.3, AutoSAR 4.4, AutoSAR 4.5, everything. So this is a way actually AutoSAR has grown up. This is the way AutoSAR is actually helping everybody to work in the market or work in the automotive side. And the V models design, I'll come a bit later. This is a AutoSAR architecture. Basically, AutoSAR has 3 layers. One is application layer, another one is RT, another one is base software. And base software is actually tightly coupled with the microcontroller. So if you see there, all application development will happen in application layer. In the basic software will contain all the necessary things in the basic software side. RT is the guy, runtime environment will be helpful to connect your basic software to application layer. I can show some parts from this videos too. And before start this, I really want to cover it up. The ASpace related topics. So somebody is already knows about ASpace. ASpace is nothing about automotive software process improvement and capability determination. So why I want to jump from AutoSAR to ASpace? So this ASpace is also a standard which will be followed in automotive for the software development process. So ASpace is nothing about automotive software process improvement and capability determination. Who is already working in a company in automotive side or automotive sector, you are already well aware about the ASpace. So how exactly this is how exactly ASpace will be functionally working in your project or your automotive industry, that's you are already well aware. But who already new to this field, I will just explain about how exactly this ASpace coming to the automotive industry, and how AutoSAR also will be related with not exactly the AutoSAR but complete development process and the project overflow, how exactly will happen in automotive industry, that's we will discuss now. So you are well aware of the V model from your other project or in your college days. Everywhere V model is a very famous one, generally followed in the industry for the complete project overflow. So you will have a requirements, architecture, design, and implementation. When you have implementation, then you will do the unit testing. When you have architecture and design, then it will be integrated with integration testing. Whenever you have requirements, it will be performed with the requirement testing. That's exactly called the V model. The same thing will be taken care in the ASpace perspective. Then if you see, this is more system level and software level and testing level. So when it is coming to ASpace level, the same V model will be followed in automotive industry with a specific method or with a specific style that's called as ASpace. Okay, so whenever the OEM requirement comes, first this will go to the system team. The system level, for an example, in the complete system overview, they will have a complete understanding about the vehicle. So how many ECUs are there, how the requirement will flow, what are the requirements are coming for the particular ECU. So one system team will sit and they will do the complete analysis. So in sys1 level, you can consider in a way requirement elicitation will happen. Whenever the stakeholder requirement comes, that first will approach the system team. From there, the complete analysis will start. In the system 2, the sys2 level, the system requirement analysis will get started. Then from there, it will go to the architecture design. Then the sys4 and sys5 will be performed for your requirement analysis. Sys5 will be performed. Sys3, there will be a sys4 testing integration and system integration test will get performed. So the system team will complete having understanding about the stakeholder requirements. From there, they will give the information to the software team. So that's the same you have seen it here. So first it will do the system requirement, then architecture design, then it will go to the software requirement. That's exactly will happen in the ASPICE too. So how exactly AutoSAR playing a major role here? Why AutoSAR is for a software development purpose, exactly the SWE level. But in system side, we are actually following and majorly holding the complete requirements about the complete vehicle. But it is depends project to project, it will vary. But this is a way ASPICE is actually doing a support and actually taken over inside the automotive industry. So when it is coming to SWE, the software engineering process group, first it will go to the software requirement analysis. So whenever the system requirement analysis is over, it will SIS2 and SIS3 will be mapped to the SWE1. So software engineer will sit and will do the requirement analysis. At the same time, it will go to the software architectural design too. Software architect will decide whatever the requirement comes from system side, whatever the analysis they have done from the stakeholder, whether it will be fit into the software or not. That will be decided by the software architect. At the same time, system architect also will be playing a major and crucial role in SIS3 level. They are also checking in system level about all the possibility. Then exactly the SWE3 is for the software developer. So if you are in a development field, then you are working in a SWE3, or you already having experience, or you are majorly focusing on architect side, then there also I'll come to the point how AutoSAR will help you. And SWE3 level, it's pure coding level design, and whatever the requirement analysis done in SWE1 and SWE2, that will be taken care to SWE3. Here exactly the software code development will be done. Then whatever the development is done, that will be taken care in the SWE4. So we will do the code coverage and unit testing in SWE4. And SWE5 and 6 again for a software qualification test. SWE5 is related to SWE2. SWE6 will be mapped to SWE1. Then after that, system team will perform a testing in overall level, whatever the things are really possible, whether things are working or not. So software team will always look for particular ECU on their software, but system will completely check about the complete system perspective, whichever is possible, whether it is working fine or not, or additionally any problem is coming because of the software changes. So they're completely ensured by the system group. Okay, coming back to the AutoSAR side, how exactly system and software is actually getting benefited because of AutoSAR. You already know that currently in industry, we all are using AutoSAR. It can be a classic or it can be adaptive. But AutoSAR is a majority used in the software development, because that's what is actually showing the way for your software development or software development. So we are keeping all the components and all the development based on AutoSAR. So in the soft SWE level, the requirement analysis, it's very common. We have to check whether it can fulfill according to AutoSAR or not. But as a software architect level, again, whether whatever the requirement analysis or system requirements or stakeholder requirements comes, whether that will fit with AutoSAR or not, that level will be taken care in the architect. So if you are working as architect, but you want to really learn AutoSAR, because all the requirement level, everything is coming related with AutoSAR. So as architect, I want to really understand like how I can approach this problem, or how can I really relate to whether this will completely supported by AutoSAR or not. So all those things, then in the case, you should know about AutoSAR very proper way to work in software architectural design. And SWE3, as usual, when you are developing a software component or developing a software in C or C++, then everything will be taken care in the SWE. So this is the complete V model will be taken care in automotive industry in the name of ASPICE. Okay, and already you have again a management process group, supporting process group. Oh, these all are the different level of approach in automotive industry, especially for the so whether what all are the things are supporting. For example, if this completely supporting for software development and primary life cycle process, but when it is coming to this one, this is supporting a life cycle process, and all this MAN and REU and about acquisition process group, these all are related with organizational life cycle process. So this is related with the ASPICE. And again, ASPICE have a different kind of maturity level, and also it has a different set of levels. So every OEM will ask, I am expecting particular project to achieve or reach this particular ASPICE level. So ASPICE have level from 0 to 5. So you guys already well aware about it in your project. Maybe you are working on ASPICE 3 or ASPICE 2. Then in the case, you have to completely fulfill this system and SWE. The requirement should flow from this level to this level completely. Okay, so you have a maturity level. 0 is called basic, 1 is performed, 2 is managed, 3 is established, 4 is predictable, and 5 is innovative. So why I want to cover ASPICE in this webinar is First of all, we should understand about the automotive structure, how exactly all this project life cycle flow it's happening, and in the name of what. That's why I just want to cover it up case by here. Then coming back to AUTOSAR side, first we can take small difference between adaptive and classic. Just I'll show you the difference. So as just now we discussed about the hardware and software related, how exactly happen in earlier before AUTOSAR comes in the picture, but how exactly it's happening with the help of AUTOSAR, how we are completely independent of microcontroller, but earlier we are highly dependent on the microcontroller, your application software. That's we have seen it. And now when you are coming to the difference between classic AUTOSAR and adaptive AUTOSAR, this is the classic AUTOSAR architecture. As I have shown, you have a 3 layers: application layer, and RT, and base software. In base software, you have a 3 layers. One is service layer, another one is abstraction layer, and another one is MCAL layer. So in MCAL layer, we are completely focusing related with microcontroller. For an example, you are getting a microcontroller from company called Infineon, you can consider. So they used to deliver the driver to us, and MCAL team will do the configuration based on the hardware schematics. So MCAL team will do the configuration related with your analog pin, digital pin, PWM in, PWM out, ICU signals, CAN related drivers, Ethernet, FlexRay, stack, all the memory related with the FLS, fee, all those things related by taken care by the MCAL team. So what is their roles and responsibilities? The MCAL team have to take care in the lower level of the complete configuration, which is closely related with the hardware. So hardware is coming from Infineon, you can consider, and MCAL team is configuring based on the schematics, all the configuration. Then it will go to the IO hardware abstraction level, where we are handling the GPIO, analog IO, PWM in, PWM out, all the IO related things, sensor, actuator, and your abstraction level, everything is taken care in the abstraction layer. And in the service layer, you will have the complete services like communication service, memory service, system service. Communication service is nothing about your DCM, COM, AUTOSAR COM, CAN NM, COMM, CAN SM. All these related things are taken care in the communication service. When it is coming to memory service, the memory service will taken care of the NVM, and it will taken care of the fee, FLS, all this related data will be taken care in the memory service. And in system services, your ECUM, BSWM, SchedulM, AUTOSAR OS, DET, DEM, all this will be part of system services. So this completely combined related with as a basic software. As I mentioned, 3 layers: service layer separate, hardware IO layer, that is ECU abstraction layer, and MCAL layer. And next one is RT. RT is a very important thing which will connect your base software to application layer. Application layer cannot reach microcontroller directly. They have to come by RT. Then from their service layer, then it will go to abstraction layer. From there, it will go to microcontroller layer. Then after that, it will reach the hardware. So application layer, we will have all the software components, and from there we will connect the ports via ports. With the help of RTE, we can exchange the information from application to base software and base software to application layer. And there is a separate one more called in the base software is called complex device driver. Complex device driver is nothing about whenever you have a critical activities where you cannot completely follow the AUTOSAR, then you can create your software component in, you can create a separate software component in complex driver. I'm using the word called a software component. What is exactly a software component? It is also mentioned here. So software component is nothing about which carries a small application that carries out a small application that's called a software component. So in AUTOSAR world, whatever we are going to create, everything needs to be created as a software component. Even if you see the generic software component, whichever is available, DCM, DEM, COM, NVM, or crypto services, all will be as a software components. But that will be their service software component, and we'll have an application software component in the application layer. So this is a basic overview about the classic AUTOSAR. So these are all our layers, and this is a way we have to follow it up. So IO and MCAL related, everything will be taken care in their unique layers. So they here, if you see this, then you can easily relate with whatever I have shown here. So here earlier, application software directly communicating, that means tightly coupled with the hardware. There is no dependency. So we cannot split the application software from hardware. But with the help of AUTOSAR, everything is possible. That's what exactly you have seen it in the classic AUTOSAR here. Now, So the same thing, how exactly will be taken care in the adaptive AutoSAR? So when the classic AutoSAR is actually started from a 2004 itself. When the adaptive AutoSAR comes, automatically the earlier one will be called as a classic. Okay, so in adaptive AutoSAR, the same, everything you can approach it here, but here everything is based on API based. So here instead of RT, you have a adaptive applications. So AutoSAR runtime for adaptive application. And again, you have application layer, and again RT you can replace with ARA. Again, here you will have all the services and APIs. So that's a major difference between classic and adaptive. I can show one more picture here. If you see it here, this is a current existing system what we are exactly working on in the current model. We'll have application, we have a ECU device, you have RTAS, you have other service and peripherals you can consider. The same how exactly will be placed in the classic AutoSAR. See, your application model, it will be keep it as a software component in classic AutoSAR model. The same application model will be copied as the same software component, but the same is called as a ARA. That's for adaptive AutoSAR system. Here we have RTE, the same RTE. Here you can hear IO hardware abstraction. Then you have AutoSAR OS and COM. So these all are related to the base software. Here everything will be coming as a APIs. Here you have a bootloader, COM, ECM, but everything will come as a API by API. So here everything is based on service based. And if you see the real difference, where you will use classic AutoSAR, when you will use adaptive AutoSAR, the real use cases, normal embedded system applications where you need a more safety, those all are the places we will use classic. You can consider the engine ECU, we'll always use a classic AutoSAR. We'll never go with adaptive AutoSAR. But adaptive AutoSAR is for a modern related technologies like because of high performance computing, machine learning, artificial intelligence, V2V, software defined vehicle, all those areas will be used by adaptive AutoSAR. So you already know that what is software defined vehicle. Software defined vehicle is nothing about completely the burden will be taken care in the software. So we can do OTA related, FOTA, all the flashing and everything where happen remotely. So with the help of Ethernet stack, there we are not going to use a CAN stack mode. So there we will completely use the Ethernet stack. Then completely we'll follow the OSI layer model. So with Ethernet stack, physical layer, data link layer, network layer, all those communications related things will come in SDV. And operating system level, classic AutoSAR is using OSEK, adaptive AutoSAR is using POSIX. The programming language level, classic AutoSAR is C, adaptive is C++. And very important thing, the major difference between classic and adaptive is classic AutoSAR is a statically configured one, and it is signal based. But adaptive is, as I mentioned, is a service based communication. So it's a dynamically configured one. That is a major difference between classic and adaptive. But if you see the use cases, classic majority will be used in the more safety wherever you want, then you have to pick classic. Wherever you need advanced technologies like ADAS and all those areas, then automatically we'll move to the adaptive. There is no dynamic updating is available in classic, and adaptive, obviously it's dynamic one. And real-time requirements, if you'll consider, classic will be used for a hard real-time requirement and adaptive will be used for a soft time real requirements. This is a major difference between classic AutoSAR and adaptive AutoSAR. So till now we have seen what is AutoSAR, how AutoSAR is helping for everybody, OEM level or supplier level or tools manufacturer level, how exactly this will be more helpful. All those things we have seen, and what is ASPICE, how exactly the project lifecycle is happening in automotive side. Then we have seen about classic AutoSAR, the architecture, then difference between classic and adaptive. Now I want to really take it up to the what are the stacks we have it in, or what are the stack companies are supporting for AutoSAR related. So for AutoSAR, so if you see, currently we have very famous stack is Vector. So who all are already working in automotive, you are well aware about it. And we have ETAS, and we have EB, and we have a stacks from KSAR, and we have a stacks from Siemens too. According to classic AutoSAR, you already know that you have a 3 layers. One is RT, one is application layer, one is base software. So we need a specific tool from the particular stack provider to work on AutoSAR. So if you are going to use vector stack, then we will have the tool called DaVinci Configurator Pro for base software development. For your RT, you will use Microsar RT generator. When you want to have for application development, then you will have use the tool called DaVinci Developer. So these 3 tools will come from Vector. So whenever you are going to purchase vector stack for your project, then you will get all these tools for your development. At the same time, when you are going to purchase from ETAS, then you will have a tool called Isolar B for base software side, and RT generation, RT RTE, and application generation, you will have iSolar. And every stack provider have their own OS also. So that OS is called in it as RTA OS. So they are also supporting OS level. And when you are going to use KPIT stack, that's KSR, then tool called KSR editor. But when you are going to use an EB stack, EB are not providing the application configuration tool for working EB stack. They are only providing EB Tresa Studio for base software development and also RT generation. But for application development, you have to depend on third-party tool. Third-party tool is like System Desk, or you can use AR Text. It's coming from RTOP. So there is a lot of third-party tools available in the market. That's you can use it for application configuration development. But EB will provide the base software stack and also with the tool called EB Tresa Studio. So DSpace is actually not a stack provider, it's a tool provider. They have a tool for RT generation and application configuration. That tool called System Desk. Might be you heard about it whenever you are getting an application software component from your customer or OEM, then they used to generate with the System Desk. So that is a tool which will be used for RT and application configuration. Siemens also has a base software stack. It's called as vStar. They have a tool called Vulcano vStar, and application configuration is for Vulcano Vehicle System Architect. So currently, these all are the guys have the stacks for AutoSAR software development, but they are coming up with a specific tool itself. So that's the reason, with the help of AutoSAR, you are getting a software component from OEM, and you are only, maybe you can think about it in your project, you are only working in a base software. Then who will develop the application? That will be developed by some other company. Then RT and application development, the integration will be done by OEM. How these things are really possible? That's because of AutoSAR. But before comes to AutoSAR, these other things are not possible. The integration, development, everything will be done by only one guy. That's the particular supplier who is actually supplying a hardware. Because they have to follow their own architecture. So might be if you are working in a non-AutoSAR project, you know about the different kind of architecture. So different companies, they have their own architecture. But when the AutoSAR comes in the market, everybody are in the same line. That's everybody is following the AutoSAR architecture. Okay. So first, we should understand about the AutoSAR stacks who all are providing, but what are the tools we can able to use it when we are purchasing the stack from a particular vendor. Now from there we can move to what are the types of ARXML we can use it for automotive or AutoSAR world. What is ARXML? ARXML is nothing about AutoSAR XML file. So XML container or XML tag, we are using it for AutoSAR automotive development. That's called as ARXML. So the same ARXML will be used for all configuration, because you are well about that AutoSAR is not a programming language. It's a configuration related things. So whomever is going to work in complete AutoSAR, rather than developing, they will work on more configuration. But at the same time, do we really need to do the C code or not when you are working in AutoSAR? Obviously, you need to do, but that will come in the end. But majority of the things will be taken care in the complete configuration itself. Then when you are coming to the C code, then you need a compiler. So you will use high-tech compiler or tasking compiler, or it depends where whomever you are buying a microcontroller, from there you will use a compiler for your compilation purpose. Now coming back to the ARXML point of view. So what are the types of ARXML we have? So first of all, in application software component development, whatever the ARXML file we create, that's called as swcd.arxml, software component description ARXML. Maybe you can have one question. Okay, I'm working in AutoSAR. I never created any file with the extension of swcd, but this is not mandatory in AutoSAR. .arxml extension is mandatory. But I'm just telling whatever the file we are creating, ARXML file we are creating an application which will contain ports, interfaces, event, runnable entity, that's called a software component description file. And the same composition file also will be there in the application top level. So these all are the files will be created with the extension of swcd. It's only for a user readability. So AutoSAR is not saying to anybody, hey, you have to create with swcd. No, AutoSAR is recommending create a file with .arxml extension. But within the project, when we are working, we should have the proper understanding what all of the files will be created for indication of which will be used in application layer, which will be used in base software layer, which will be used in RT. That complete understanding, we as a developer, we should have it. And in base software side, for an example, for all your services, we are creating a file with ECUC values. Might you all have aware about it, ECUC values files when you are working in a base software configuration side like DCM, DEM, DET, COM, OS, RT, NVM, all those area. And all the base software module will have a BSWMD file as well. That's called as base software module description file. That contains your schedulable entity, measurement variables, all those information will be there in the BSWMD file. So these all are the types of ARXML files we are using it in the automotive world and especially in the AutoSAR side. Now coming to the AutoSAR side, when we are creating a software component, so what are the types of software component we generally has it? So we have a 9 type of software component you can create in automotive. That means in the AutoSAR side, when you are working on a classic AutoSAR development, there is a 9 that I will show it to you now. So what are the those 9s and what purpose you have to create all those things? If you will see the software, you cannot create or you should not, or generally we will not create the first of all we see the 9 types of software component. So one is application software component, which will be created in the application layer. So in application layer, whenever you want to create a software component for creating a one small application, or for some, for an example, you can take a application for reading the VIN number, vehicle identification number, chassis number of 17 bytes. You want to design a software component, then that's you need to design it in the application software component. I'm telling you one example. And you have another software component called service software component, like PCM, DEM, COM, all those will come up with the service software component. And sensor actuator software component, when you want to create or when you want to really interact with your actuator or IO, GPIO or analog, digital, PWM or actuator, or you want to control a motor. So all these applications, you can create a sensor actuator software component. When you want to create a software component in IO, that means ECU abstraction layer, then that's called as a ECU abstraction software component. When you want to create a software component as a complex device driver, that's CDD, then you can create as a complex device driver software component. So when you want to have a service proxy, when you want to create a software component for service proxy, then you have to create as a service proxy. For NVM, NVBlock software component. You want to create a software component for calibration, then you can create with a parameter software component. So when you want to have a multiple software component inside, then you can have it as a composition software component. So first of all, you will have a composition software component. Inside the composition software component, you will create an application or sensor actuator, depends on your project purpose. Inside the software component, you will have a ports. So these are the types of software components will be used. So this is a way the software, this is one sample how we can create a software component. Okay, what exactly will be there inside a software component? That's I will show you now. So every software component will contain, I can show you. Every software component contains ports. The ports will always be mapped with the interfaces. Then every software component contain the internal behavior, how the particular software is going to behave internally. That's called as internal behavior. So internal behavior contains events. This called as RT events. You might hear about the timing event, data received event, data sent completed event, operation invoked event. Like this, you have a 18 kind of events in AutoSAR. That's called as RT events. You can see there the sample of one application software component. Here we will have a ports, then internal behavior. Every internal behavior contains events, exclusive area, and data type mapping reference. But exclusive area and all, it's optional. You can have it or you can leave it. It's up to your application. And data typing mapping reference is required whenever you want to map your data type. Whenever you want to do the data type mapping reference. And you can have an interrunnable variable, you can have a per instance memory, port API option, runnable entity, and whether it is supports multiple instantiation or not, all those information you can have inside internal behavior. But if you will ask me, okay, is everything is optional? No, you should have a events and you should have a runnable entity. Runnable entity is nothing about your C function definition. So whatever the function definition you want to write it, but you want to invoke via RT, then that you have to mention it in the runnable entity. So whenever you want to exchange information between the same software component from one function to another function, then you should have an interrunnable variable. Then whenever you want to create a calibration related, then you should have a per instance memory. So whenever, for an example, port API option will be majorly will be used when application component software component want to write the data in NVM, but application software component doesn't know about your NVM block ID, then these are the cases you have to use the port API option. So like this, every software component contains ports. Ports should be associated with interfaces, then internal behavior, all these options. Then we have three kind of ports. One is P port, R port, and PR port. P port is for providing a data, R port is for receiving a data, PR port for providing and receiving a data. So if you want to use the same port for sending and receiving information, then you can use the PR port. When you want to receive the information, they can use R port. So when you want to send the data, then you can use the P port. So these all are the real things will be used in the AutoSAR. So when you are designing a software component, you can have a sender and receiver software component. Then it will become called as a sender receiver interface. So when you want to exchange the information via sender receiver, when you want to exchange via client server, then it will become a client server. So P port will called as a sender, R port will called as a receiver. Here P port will become a server, R port will become a server client. So what is the difference between sender receiver and client server? So before jumping into this, you can see this. So this is a way you have to design a P port and R port. So here these all are the things I designed it, but this is a way you are after your configuration. If you will see in your XML file in any of the viewer like Notepad++, then you will see like the same way. Okay. Then what all are the interfaces are there in AutoSAR? AutoSAR, like you have sender receiver interface, client server interface, then you have a mode switch interface, internal trigger interface, external trigger interface, then NV data interface. So major important thing or very familiar one will be used is sender receiver interface and client server interface. So sender receiver interface will be used for whenever you want to exchange a data less than 4 bytes. It's like a signal in COM. Whenever you want to exchange a signal information, then you will use a sender receiver interface. But whenever you want to exchange a data for more than 4 bytes, like function call or function invocation, you want to exchange 50 bytes of data, 100 bytes of data in like DCM, DEM, you want to read 100 bytes of data, then in the case you will use a client server interface. Okay, so this is what very basic level information about AutoSAR. What is AutoSAR? Why AutoSAR? How AutoSAR is helping automotive industry? So why we need to follow ASPICE, especially in the automotive software lifecycle, and how AutoSAR helps ASPICE. At the same time, what is the difference between classic AutoSAR and adaptive AutoSAR? And what is the difference between the layers like application, RT, and base software? And what all the ports are there, how you have to design a software component, what all the information you will have it inside the software component, all those related things we have seen it now. So this is basic overview about, because it's almost 45 minutes we crossed it. So I want to hand over to Venkatesh now. So this is what the basic information about AutoSAR. So my recommendation is when you want to learn AutoSAR, you should know about all these related stuffs. But AutoSAR is actually a very big one. But whatever I just communicated or whatever we discussed now, this is actually some overview about AutoSAR concepts. But there is a lot of internal things are there for AutoSAR. Yeah, Venkatesh?
Yeah, thank you, Mr. Ganapati. There are some questions in the chat window.
Yeah,
Can we cover them first?
Yeah, sure, definitely, I can. I can come.
Can you scroll up? Yeah. First question is from Madhusudan Ashok.
Yeah, well, yesterday can fit on multiple time ASW is like a common platform used in all base with respect to supply changes. Yeah, so ASW is about the application layer. It's nothing related with base software. That's why. So if you are an example, you want to design a door control ECU. So you want to design the door control indication. It's one of the things you want to design it, or you want to read the VIN number, or you want to read the system time, or whatever the application related things you want to have it, that's you can have it in ASW. That's again, it's nothing dependent with base software. It's again depends on your requirement and project level. For an example, when you are working in a project, but that same thing is applicable for a multiple variant. Obviously, we are developing it, but the same thing can be taken care for multiple variant, right? At the same time, if you are developing application software component for one variant, the same thing you can take it for other variant too. So that's why AutoSAR is supporting that. You can reuse all your software component which you are designing in ASW. And there is a question from Jagannathan. Seems this session is only for classic AutoSAR. Classic, yes, exactly. This is nothing only about a classic. But before jumping into the adaptive, my recommendation and my basic level experience is you should learn about the classic first. Then adaptive understanding is very easy. And classic is actually you can learn a lot. At the same time, Adaptive also, that's what. Application wise, classic and adaptive will vary. A classic will be used for a safety and other area, engine control unit, and multiple areas, but adaptive is for future related SDV, ADAS, and high performance computing because of Internet of Things, machine learning, all those related. So my recommendation is learn classic AutoSAR first, then you can jump to adaptive AutoSAR. Then you can easily relate the things in adaptive AutoSAR. And Venkatesh, all the questions, okay, that's you mentioned. Yeah, MCAL team will be in OEM or Tier 1. No, MCAL team is again, it depends in the base software side who is actually developing. MCAL team will be there in OEM side also. MCAL team will be in supply side also, service team also. But it's again, they will work on base software MCAL layer. Their ultimate job is they have to do the configuration, which is closely related with the driver related with hardware. For an example, CAN related, you want to CAN transceiver is actually, and CAN driver is in MCAL. It's coming from a microcontroller provider like Infineon you can consider. So MCAL team will do the configuration of baud rate, CAN address, all those related information in MCAL level. So because the first things will come to MCAL because they are only closely interacting with hardware. So IO configuration, you can take digital input. You want on and off consideration. You want to motor on, motor off. So in the case, they will have a port configuration. So that can be a GPIO or digital in, digital out. Such a kind of configuration will be there in the MCAL. But they also will be do this design based on the hardware schematics, meaning your ECU schematics. So as per explain, MCAL is supposed to be with Tier 1 or whomever is developing the AutoSAR protection for hardware. Yeah, exactly. But that is the thing. So service related things, companies are majorly will focus on the service level, but it's again, it depends. Everybody can work in MCAL. There is no restriction like, but the schematics which is coming from a hardware supplier, they will have all the MCAL related things. But there are companies are working on taking external employees from a service companies. They are doing a development. They are helping for MCAL related. Everything is possible. So no restriction. It's again depends on the business model. So semiconductor companies, yeah, semiconductor companies again, if you majority we are thinking about a ECU level, electronic control unit level. So where we are getting a hardware or microcontroller from chip companies like Infineon, that means IFX Elevator, Tricore, TC389, and Renesas. They are also one of the strong major holder in automotive applications. So those are the companies actually delivering a microcontroller to the suppliers where they are manufacturing a hardware. So BSWMD file, it's actually contains the base software module description file about your, you can take example for schedulable entity or measurement variable related information that will be there in the BSWMD file. So how model-based design fits in AutoSAR? Yeah, MBD is actually one of the things where you want to really development the software component, everything in MATLAB, then you can use that's called as model-based development, model-based design. The thing is, you can design software component in application in multiple ways. One is you can manually do it in Notepad++ if you are too good at AutoSAR. Second one is when you are buying a stacks from the companies, they are also providing a tool from the, like if you are buying from ETAS, then you will have Isolar A. When you are buying from Vector, you will have a Vector developer. So you have a system desk. So you can use all those tools also for a software component development in application layer. At the same time, you can use MATLAB and you can do the complete generation also. So that's why model-based design also fits in AutoSAR. Yeah, then how AI will be useful in AutoSAR? AI is actually kind of application. It's nothing related with AutoSAR. So when you are coming or discussing with the SDV, software defined vehicle, obviously we need a Ethernet stack. What is the reason? Because we want to communicate with the cloud, external world. So then we need a Ethernet stack. So when you need a Ethernet stack, then completely your flow will change. For an example, diagnostics, some IP, DOIP, everything will come in that. So SDV also need a machine learning, artificial intelligence, software defined vehicle. So this is the way everything is collaborating. But AutoSAR is not talking anything about AI. When the AI, IoT, everything comes, AutoSAR is also ready to support such a kind of application. But there is no direct relationship between your AI or IoT to AutoSAR. AutoSAR is only for software development. It's providing a platform of software development for automotive applications. So how can we do the requirement change in SWE 5? No, you cannot do any requirement change in SWE 5 and 6. You are actually writing a test cases in SWE 5 and 6 by evaluating your SWE 1 and 2. So SWE 2 will go to SWE 5. SWE1 will go to SWE6. So based on the requirement, the software testing team will understand the requirement, then they will write the test cases. Then they will go for a test case execution. Then from there, they will identify the bugs and they will report to them from their understanding. But SWE5-6, it's pure for testing. Nobody is altering a requirement there. Maybe you are identifying a bugs, then later the SWE1 responsible will analyze it. Then they will understand, hey, this requirement will not fit whatever development we have done. That's possible. But SWE5-6 purely for testing. So 4 bytes from Magesh. Sender receiver port, more than 4 bytes. Can we use CS port? Yeah. So this is actually not mentioned anywhere, but when you are practically working sender receiver interface, when you are coming to sender receiver interface, basically we will exchange the data via RT write and read. So then in the case I can show you, since it's a good question again. I have one video for you. It will not take much time. So sender receiver interface, when it comes, you have a 2 possibility of communication. One is implicit, another one is explicit. So that's I can show you with the proper picture. See there, this is what. So when you want to communicate from sender software component to receiver software component, one sender, one receiver, here multiple sender, multiple receiver, there is a non-queued and queued communication. When you want to write a data from one software component to another software component, you will create a variable. So variable you can consider unsigned 8, unsigned 16, unsigned 32 or unsigned 64. So you will mention your implementation data type or your application data type. In AutoSAR, you have a 3 kind of data type. One is implementation, another one is application. There you can have an application primitive, application record. So here sender receiver interface always will be used to create a variable. That variable you can create as array, or you can create as a normal 1 byte variable or 2 byte variable or 4 byte variable. So that is why I just, for the clarity, I have just given information or make a difference between sender receiver to client server is we are preferring the sender receiver whenever you want to exchange the data via signal. That's why you are always in a sender receiver whenever you are sending a 1 or 2 bytes or 4 bytes data via CAN. That means in AutoSAR COM. So software implementation policy will be deciding whether you are using queued mechanism or non-queued mechanism. So because we don't have much time, I want to directly jump here. See there, the sender receiver communication summary. You have a 2-1. One is implicit, another explicit. Explicit you have non-queued, queued. So it depends on your attribute inside a runnable entity, whichever you are choosing. Based on that, your API will get generated. So fully we can able to write or send the data, you can read or receive a data. So here we are not making any function call. So again you can ask, RT read and RT write is a API call, obviously, but we are not using any function call for just reading a data, right, punch of data. Like whenever you want to send 50 bytes of data from one software component to another software component, we are not preferring sender receiver, because client server is a very fittable one to exchange the data between one software component and another software component. That's why I just took an example for sender receiver information about 4 bytes information, nothing more than that. And can AutoSAR classic and adaptive coexist? Yes, exactly. This is also possible in some of the projects. You can use it for classic and adaptive. For one ECU will support classic, another ECU will support adaptive. Then this can able to communicate it. That's completely possible. So almost
yeah.
Yes,
so one extension, like it's also a common question, like in the future will classic and adaptive AutoSAR coexist, not just in a specific.
That's possibility are there, but that depends on the application again. So if we are going to get such a kind of application, we will use it. So that's only for an example how we are using CANFD all together. Same way we will come up with a situation, but as of now, classic, as I mentioned, it will be used majority for more secure related applications. But definitely it depends on application and project, it will exist. Yes, Venkatesh.
Thanks, Mr. Ganapathy. Folks, like just an announcement from our end. Thank you so much, Mr. Ganapathy, for your valuable time here. We are launching a Classic AutoSAR certification program in which Mr. Ganapathy will be the instructor. I'll just share my screen and give you details about the program. I've also shared a feedback form in the chat window. Please fill your valuable feedback. It will help us improve your overall experience and what we need to convey in our series of webinars. Right. So going back to the certification program, essentially we are launching a Classic AutoSAR for automotive software development certification program, which will be powered by your EB tool. Right. So I'll just dive into the program structure. So the program itself is for a period of 6 weeks of time. In the first 3 weeks, it will be 40 hours of live instructor-led sessions, which will be handled by Mr. Karodia himself. And across these 3 weeks, 9 modules of sessions, 9 modules of topics will be covered, which will essentially cover end to end of everything that is related to Classic AutoSAR. And in each of these modules, there will be plenty of hands-on projects as well as assessments. In the second part of the program, that is week 4, 5, and 6, there will be a capstone project integrating everything you would have learned in the first 3 weeks. So this is the major structure of the program. And we have partnered with Electrobit here and you will have access to 45 days of EB Trezor WinCore and EB Trezor Studio in your local system. You will be able to utilize it through the entire period of 45 days, through the entire period of 6 weeks. And the live sessions will be recorded and you will be providing that, you will be provided the access to that for a period of 3 to 6 months. And I'll just go to the curriculum. I request Mr. Karodia to try this.
Yeah, thank you, Venkatesh. Yeah, yes, exactly. So this course, actually, completely the 45 hours will be taken care from the basic level AutoSAR to high level. So I'm planning to cover it up with AutoSAR OAS, the AutoSAR overview, applications, how you can create a software component, everything practically, not much theoretical, and how you can work with RT, how you can do the connection, application, assembly connection and delegation connection, how exactly the COMM, BSWM, ECM level it works, and startup sequence, end of sequence, like how it will start from ECM level, then where it will jump all those complete sequence level in the startup, also in shutdown phase. And this complete sessions will be taken care related with the IO stack, how you can create a CDD, and in when you are going to create a software component, how you can create a different kind of software component, how you can communicate from one software component to another software component, how you can use a sender receiver interface, client server interface, complete interface level. And additionally, in the base software side, I will cover up with the diagnostics, DCM, DEM, and how you can work with COM, how you can create the blocks for NVM memory level, and also how you can relate it with how you can use a CAN stack, all those related information. And when it is coming to advanced level, we will focus on the autos, how you can really design AutoSAR OS, meaning not complete from scratch, but how you can create a basic task, extend a task, how you can do the event to task mapping, all OS level related configurations level, and informations about MCAL. But since as Venkatesh mentioned, this is a virtual MCAL it has, you cannot really feel anything related with real hardware, but that's my responsibility to completely explain practically from scratch to top level. So Venkatesh, can you scroll down a bit? Yeah, so once this complete all classic AutoSAR related, if you see how to work in application layer, how to create a software component, how you can connect the ports, how you can interact with RTE, how you can do the RTE phases, contract phase and generation phase, and what all the other things are there in RTE. Then when it is coming to base software, DCM, DEM, COM, SecOC. And so when you are coming to security related, I will explain about the SecOC communication and end-to-end CAN related and memory stack related, and ECUM, BSWM configuration, how you can create a logics in BSWM, action list, rules, logical expression, all those related information. And also parallelly, we will guide you to from your end. You can also work on the integrated project at the same time. 2 days once, I will give the homework to everybody, and I also will follow it up with them, how exactly things are going on. And you can reach me anytime, like whenever you have a practical problem, because everybody will get an individual license for 45 days. So it's a very golden opportunity for you all to utilize and to learn about AutoSAR completely from scratch. I'm telling you again, today we have only 1 hour. That's what I have fast up all the topics. But when it is coming to practical application, we'll go step by step with complete practical applications. And you will have a recorded session as well. Later you can refer it. I will show from my side how you have to configure in EB. And as I mentioned, multiple stack. Here we are going to use a EB stack for base software development, and application layer we will use a AR text, and RT again EB related. So additionally is in your project, if you are working in EB, it's again opportunity, or if you are going to work in EB stack in future, then you will come to know how you can really work with the EB stack. Okay, and this completely related for learning purpose, because we are not going to have any ECU to keep on and from there we are not going to show any demos. No, it's a pure software demo because AutoSAR is for a software development. So other related things you already well aware. That's what we are taking care in a complete stack configuration, also related with how you can practically experience the AutoSAR. And once this complete project or this complete session is over, we will hand over the project to 10 to 15 projects we are planning from our end. Some example for the project is how you can create simple from basic level to top level, how you can create a door lock related applications, and we will allow you to create in a multiple projects for battery health monitoring, and how you can take the engine speed and how you can store it. So how you can do the base software development, how you can do an application development, and finally for compilation purpose, we will use Eclipse where you can compile and you can see all your outputs. And we will teach you along with this related with complex device driver development. And additionally, if you need any other information, we will cover it up. I will cover additionally post-fill configuration, post-fill selectable, post-fill loadable. All those areas also will be covered from my end. So one thing I can give the confident and things to is this program for from scratch to top level. So 45 hours, and apart from that, if you need any support also, Skilling will support you for clarification of queries, everything. And you will have again a live session. So whenever you want, you can go through it. Yeah, timings and other related things, Venkatesh will inform you. And adaptive AutoSAR related information also, theoretically we'll cover it up. But EB, whatever the stack we have right now, that's purely supporting only for a classic AutoSAR. But adaptive AutoSAR concepts, that's we will teach you. That's you no need to worry. Adaptive, that's how adaptive AutoSAR works. What are the things will be there? Theoretically, we will teach. Yeah, Venkatesh, they are asking about fee and timings.
Yeah, definitely. Thanks, Mr. Ganapati. So, folks, like, please make sure to fill the feedback form. You can request for a callback in the feedback form. We'll get in touch with you one-on-one to discuss more about the program structure, fee, and the timings. So we are planning to start the program from November 18th onwards. Like Mr. Ganapati mentioned, it will be 6-week long program. First 3 weeks will be the live virtual sessions, and the next 3 weeks will be the project sessions. And yeah, any other queries with respect to the program also, you can mention it in the feedback form. I'll personally call everybody who have requested in the feedback form, and we will have a wider discussion. We want to do this away from the call and give one-on-one attention here. That's the reason. Anything else you guys would like to know about the webinar or anything related to AutoSAR? We have another 10 minutes. Please feel free to post it in the chat window.
Yeah, and this session will be helpful who really want to enter into the automotive world. You already know that AutoSAR is actually ruling it now, and it's not going to end story within 1 or 2 years. It will be a long story. So who already working in a project, if you're in 3 or 4 years experience, but I don't have a full clarity on how exactly things are working, then this session will be really helpful. And who really want to enter into that, you are in a college level or you are really focusing on AutoSAR, then this would be more helpful. Even though if you want to understand, maybe you can say that I have a 7 years experience. I already know AutoSAR, I'm working on my project, but not very deeply. Then in the case here, you will come to know because of practical explanation, you will come to know each and everything. As I mentioned about, I have shown the table in my YouTube video there, all the RTE APIs, each and everything you can practice yourself. Even though maybe you can ask a question, okay, you are only 45 hours, how? I can provide all the problems and challenges every day. Once that session is over, I can describe whatever things you can practice. And when you are facing a problem or when you are ending up with the error, you can reach me in the next day and we can connect and we can solve the error. Then, so this is a way you can really start to learn it. So this is a good opportunity. And at the same time, if you feel I have a 10 years experience, but still I'm going to work in a AutoSAR project, whether it will be really helpful for me because you are only focusing on a scratch, that means in the base level, then it's not going to be helpful for me. No, because it's a 45-hour session. As I mentioned, I will come up level of SecOC in E2E level, end-to-end encryption, transformer level. That might be you doesn't hear about some words, and post-fill selectable, post-fill loadable, all those areas we will cover it up. So one thing is, whatever the money you are going to spend it, that's we will take a responsibility to provide all the information to you which is really required. And if you want to crack interview in AutoSAR, or whenever the AutoSAR question comes, you can, I'm giving 100% assurance, you can definitely crack it. And when you are working and you want to take AutoSAR interview also, these sessions will be more helpful to you. Yeah, please, you can. There is one question about what about vector Canova DaVinci configurator related get introduced. No, this is completely related with the EB stack. It's not about a vector. But if you ask me, I have a very good experience with vector, ETAS, and EB. So if once you get a practice with EB, you can easily work in ETAS or vector, because these are all the tools. Everybody following AutoSAR. Only you have to learn AutoSAR. The tool is not a matter. Example is, if you know C language, you can use any tools for C language. You can work in Arduino, you can use GCC compiler, or you can work in HackerRank, you can use Geeks for Geeks IDE, you can type a code anywhere. You no need to worry about what compiler they are using. You can work in MinGW, or you can work in GCC, the same way for AutoSAR. If you know AutoSAR, you no need to worry about the stack. Stack you can learn in a day if you know AutoSAR. So, but this is, we are not going to cover anything specific to vector tools. It's for only EB. And one more thing is, we are not going to talk about anything tools related. We're not going to bore you. Pure technical content only we'll focus it in the session.
Thank you, Mr. Ganapathy, for the assurances.
You.
Folks, please make sure to fill the feedback form. We'll get in touch with you. Any other queries with respect to the program, anything else, you can add it there. I'll personally call everybody here. We will share the recording of this session on by Monday, Tuesday. Also, I think there is one question about the certification program itself. Yes, the live sessions will be recorded and it will be available on the LMS for your access for a period of 3 to 6 months.
Guys, please ask if you have any questions. Anything about technically, if you need any, maybe with this topic will cover it up or not, that topic will cover it up or not, I can answer it. We have 6 more minutes.
So Ganapathy, if you have that project slide,
I can share it with you, Venkatesh.
Yeah.
Yeah, you can share it with them, whomever is interested. The complete overview, what are the topics, we'll cover it up. That's also I'll mention that. Yeah. Venkatesh, there is a question from Agarwal Sonia.
Yeah, Sonia and others, like the course fee, the standard fee of the program is 55,000. It's right now we are running an early bird offer on the same. You can avail the program till now, October 25th for 50,000. If you have filled the feedback form, please expect a call from my tomorrow. We'll have a detailed chat on the entire structure as well as details about the session timings and whatnot. Mr. Ganapathy, there is a question about.
Yeah. Hello, Mahesh. Mahesh, actually, this is majority this course for AutoSAR, but diagnostics CompStack, maybe Skillink can plan separately for dedicated for diagnostic stack, because it's actually worth of having a separate session in diagnostic and CompStack. But this session is purely for combination of diagnostic and comp. So you will get a practical experience again with AutoSAR, because there is also AutoSARs will be used, but no specific purely about diagnostic stack. No.
What percentage of the program will be on diagnostic and CompStack, Mr. Ganapathy?
It's about, you can consider, Mahesh, it's about 10 to 15%, because we have to cover it up all the topics. Especially you have to understand the AutoSAR, but 10 to 15%, I'm giving the assurance, we will cover it up diagnostic and CompStack. And MEMStack, cyber security stack, everything. Whichever is really required to work in automotive industry, that we will cover it up. But more practical in AutoSAR.
Thank you, everybody. I'm dropping the feedback form again. We'll keep the session open for the next couple of minutes. Thanks, everybody, for joining in on a Friday afternoon. Thank you, Mr. Ganapathy, for your valuable time.
Thank you. Thank you so much. Thank you all. Have a nice weekend.